Hey Kipsters, happy Thursday. We're going to jump right into the simulation work for our lesson for today. As you may remember, you can log into Amplify and complete the steps by logging into Clever first and then finding the Amplify application. Let's read through our steps for the simulation today before we get started. We are going to use the sim to investigate how the temperature of the air can affect the amount of rain. Step 1. Launch the weather pattern simulation in Regional Weather 1 mode. Step 2. Set up your weather event by changing the temperature only. Leave surface water level at 5 for all storms. Make a weather event: cloud with severe rain, cloud with moderate rain, cloud with very severe rain. Step 4, run and observe what happens. Step 5, click Analyze and look at the blue rainfall level in the bottom right corner to see if you got the weather event you were trying to make. Step 6, while in Analyze tab, record your data on the chart below. Step 7, repeat steps 3 through 7 for the next storm. Okay? So here are the 3 tests we're going to be completing. Test 1, cloud with severe rain, rainfall level of 3. Test 2, cloud with moderate rain, rainfall level 2. Test 3, cloud with very severe rain, rainfall level 4. And we're going to be filling in all these different data points for each one. Right now, I want you to pause this video and make a chart like this in your notes. So take out a piece of paper, a pen if you haven't already, or a pencil. Draw this chart so that you can fill in the data with me. Okay, step 1, launch the weather pattern simulation in Regional Weather 1 mode. So when I'm in Amplify, I'm going to click the 3 bars. I'm going to look until I see the weather pattern simulation. Here it is. Now to get to the right mode, I'm going to click the 3 bars, and then remember I want Regional Weather 1. Yes. Awesome, okay? And then remember we're changing the temperature only. And the surface level for water is going to stay at 5 for all storms, okay? So I'm going to make sure that I set the surface level water to 5, okay? Set it to 5. We're changing the temperature only. Test 1, severe rain, rainfall level 3. Okay, so I'm going to jump to step 3, make a weather event, cloud with severe rain, rainfall level 3. I know that the amount of sunlight is going to change how warm my air parcel is. I'm going to set my amount of sunlight to a level 4 because I know that's going to warm up my air parcel enough to create a lot of rain. If I were to set it at 0, I would not be warming up my air parcel and no rain would happen. If I were to set it at 5, I would probably create a very severe rainstorm. So I just want a severe rainstorm. So I'm going to set it at 4. Okay, I set it at 4. Make sure you are clicking that in your document. Remember, I am trying to create a severe rainstorm. Why did I set it to 4 so high? Because I want a warm air parcel so it'll rise high in the atmosphere, and then there will be a lot of energy transfer and a lot of rain, okay? I set the sunlight to surface at level 4, which is pretty high, because I know that the strong sunlight will cause more water to evaporate into water vapor and create a warmer air parcel. The more water vapor that an air parcel has, the more rain it can produce. The warmer an air parcel is, the higher up it will rise in the troposphere, which will create a bigger temperature difference between the air parcel and the surrounding air. The bigger the temperature difference, the more energy will transfer, causing more water vapor to condense into liquid water and fall as rain. Okay, now I'm going to hit run. I see energy transferring from the sun to the earth, which warms the air parcel, and now I see water evaporating into the air parcel, and once it reached a certain temperature, it started rising into the troposphere. Energy transferred out as it was rising, and now we have that water vapor condensing into liquid water and forming rain. Okay, so we're done. We're going to hit analyze. So now, first thing we want to know is, when did the air parcel stop rising? Okay, the air parcel that we saw, it stopped rising when it became the same temperature as the surrounding air. So as you can see, the air parcel temperature here is 30 degrees Celsius, and the troposphere temperature is also, negative 30 degrees Celsius, and the troposphere temperature is also negative 30 degrees Celsius. So when did the air parcel stop rising? When it became the same temperature as the surrounding air. Okay, let's analyze our data. Remember, I am trying to create a severe rainstorm with a rainfall level of 3. Did I achieve my goal? Okay, so if I look at my data, I see that my rainfall level is at 3. So yes, I got a rainfall level of 3. Okay, right now pause your video and record the data for each of the boxes. All right, welcome back. What was the air parcel temperature difference? So if I want to find this, I'm going to look for the box that says air parcel temperature difference. Okay, right here, air parcel temperature difference. I see that it was 65 degrees. So I'm going to click 65 degrees. Is that a big, medium, or small temperature difference? That is a big temperature difference. That is why we got a lot of rainfall. The temperature difference of 65 degrees Celsius caused a severe rainstorm with a rainfall level of 3. The bigger the temperature difference, the bigger the rainstorm. Test 2. Now we want to create moderate rainfall. I'm going to go back to build. My surface water is at 5. I want moderate rainfall. I'm going to bring it down to 2. What did I set it at? I set it at 2. Remember, I'm trying to create a moderate rainstorm. Why did I set the sunlight to surface at the level I did? I set it at level 2, which is moderate, because I know that the moderate amount of sunlight will cause a moderate amount of water to evaporate into a moderate amount of water vapor. This less water vapor that an air parcel has, the less rain it can produce. The air parcel won't be very warm because I set the sunlight to surface at level 2. The air parcel won't rise as high in the troposphere because it isn't very warm. There will be a moderate temperature difference between the air parcel and the surrounding air. The moderate temperature difference will cause a moderate amount of energy transfer, causing a moderate amount of water vapor to condense into liquid water and fall as rain. Okay, let's see what happens. I see a smaller arrow of sunlight warming the air parcel. I see a smaller arrow of water evaporating. I see the air parcel only got to 25 degrees Celsius this time. I see less energy transferring out. The air parcel did not rise as high up in the sky, in the troposphere. And I see less rain being produced. Okay, I'm going to go to analyze. Remember, I am trying to create a moderate rainstorm with a rainfall level of 2. Did I achieve my goal? Yes, I got moderate rainfall at a level 2, so yes. Pause the video right now. Look at the data that you have. Look at the data that you have and fill in the table. You can also look at the picture above. What was the air parcel temperature difference? So I go to test 2 and air parcel temperature difference, it was 50 degrees this time instead of 65. So I'm going to hit 50. Is that a big, medium, or small temperature difference? That is a medium difference. It's smaller than 65, but it's still a decent difference. The temperature difference of 50 degrees Celsius caused a moderate rainstorm with a rainfall level of 2. The smaller the temperature difference, the smaller the rainstorm. Last test, very severe rain. Okay, now we get to create the biggest rainstorm yet. So, I'm going to go to build. I'm going to increase my sunlight to surface to the maximum possible amount of sunlight. That'll warm my air parcel a ton. I'm going to hit run. I see this giant arrow of energy transferring to the air parcel. I see a ton of water evaporating, this bigger arrow. My air parcel temperature is now 40 degrees Celsius. Look at how high this air parcel is rising into the atmosphere. A ton of energy transferred out, and we see a ton of rain falling. Now I'm going to go to Analyze. I'm going to look at my data. What was the air parcel temperature difference? The air parcel temperature difference this time was 75 degrees. Right now, pause. Make sure that you record the new data for test 3 and that you select 75 degrees. Is that a big, medium, or small temperature difference? That is a very big difference, right? The most severe storm had the biggest temperature difference. The temperature difference of 75 degrees caused a very severe rainstorm with a rainfall level of 4. The bigger the temperature difference, the bigger the rainstorm. Analyzing patterns in the data. Okay, so remember, each storm had a different starting air parcel difference. The temperature difference. The starting air parcel temperature for test 3 was 40 degrees Celsius, the biggest storm, and then the moderate storm was only 25 degrees Celsius. So the pattern we see in this data is that the warmer the starting air parcel temperature, the more rainfall happens. How did the amount of energy transferred out affect the amount of rainfall? So if we look at this last column, the amount of energy transferred out, our big rainstorm, test 3, had 194 megajoules of energy transferred. Our smallest storm, the moderate storm, only had 129 megajoules. So we know the more energy transferred out, the more rainfall can occur. All right, Kipsters, make sure that you watch this video again if it was too much information at once, so that when you take your exit ticket, you can crush it. Keep up the great work.